In this video we have two functions, an exponential and a logarithmic function. The first one we have f of x is equal to 3 to the x, and then g of x is equal to the log of x to base 3. We want to find each of the following values. So we're evaluating these functions at the given values. So for number 1 we have f of 4. So we look at the function, evaluate it at 4, and since it's 3 to the x, we simply plug in 4. And 3 to the 4th power, 4 factors of 3, 81. Okay, g of 9, I'll just put it equal here, refers to the log function. So it means we're evaluating that one at 9, base 3. That would be the log of 9 to base 3. So we're asking 3 to what power gives me 9? Well, of course, it's 2. The log of 9 to base 3 is 2. Number 3, we go back to the f function. We want to find f of negative 2, and f of x is 3 to the x. So we put 3 to the negative 2, and using the rules for negative exponents is the same thing as 1 over 3 to the second. 3 to the second is 9, so this would be 1/9. The next one, back to the g function, g of 1 over 27. So evaluate the g function at 1 over 27. That would be the log of 1 over 27. But I can write 1 over 27 as 3 to the negative 3. So this base is 3, this base is 3, the answer is negative 3. Or we could say, or ask, 3 to the negative 3 equals to 3 to what power? Negative 3. So we're saying the log of 1 over 27 is negative 3. Okay, for number 5, same sort of thing now. We have f of negative 4. Using the f function, this would be 3 to the negative 4. That's the same thing as 1 over 3 to the 4th, or 1 over 81. So f to the negative 4, the value of that function is 1 over 81. Number 6, go back to the g function, and we want to find g of 1 over 243. So this is going to equal to, using the g function, this will be the log to base 3 of 1 over 243. And 243 is the same thing as 3 to the 5th power. So I can write this as 3 to the negative 3. It'll be 1, and then 3 to the 5th, take this upstairs, change the sign of the exponent to negative 3. Now again, I can say, okay, base 3 and base 3, you know that by laws of exponents, or laws of logarithms, I should say, this would be a negative 5. Or we can just use the definition of log. We're asking 3 to the negative 5 is equal to 3 to what power? Well, it has to be negative 5. Now the earlier video, might have been the last video, I mentioned that the log function and the exponential function are inverses of each other. Have to have the same base. So this is 3 to the x, and this is the log of x to base 3. So these are inverses. And we had mentioned that the inverses composition, if you take one function, say f, and you find its inverse, which is what we did the last video, the inverse, and we take the composition of one with the other. In other words, f of the inverse or f inverse of the function, it's always x. So with that in mind, this has to be x, and this has to be x. But let's go ahead and set it up. So f composition g is equal to, so we have to look at this to start off with. So it's going to be 2, or I should say 3, f of g of x is composition of f with g. So this will be 3, and then the g function, evaluate it, would put this up here. Then you can apply your properties of logarithms, or just what I just said about inverses. This base is 3, this base on the log is 3, so it's always going to be the argument. That's going to be x. And over here, we reverse this, g of, so take the g function. This is going to be the log to base 3. Evaluating g at f, and f is equal to the exponential. This will be 3 to the x. Because they're inverses, we know the answer, but also we use the properties of logs. Again, this base is 3 and this base here is 3. The answer is always the argument here, and that's equal to x. Thanks for watching. We'll see you next time.